Hello guys, welcome to my YouTube channel. All right. Hey, so today I've come up with a very interesting problem. Uh, it's a medium level problem, but it can get confusing, and I want to do it like a two video kind of series. So I want to do so this one is like serialized, deserialized BST, and then another one I want to do probably in the next video is a serialized, deserialized binary tree, and this is BST. So. Yeah, I hope you know the difference. It's this the BST, there is a rule that your left node is always less than or maybe equal to your parent, and right is always greater than or maybe equal to, in some cases, again, to your parent. So, with that said, let's go take a look at this. So, serialize, deserialize BST. So here we have been given a tree node, and the idea is to serialize. That means to convert it into some kind of a string, right? Um, so, and then deserialize again to take that string and reconvert that tree. So my idea over here is, uh, okay, so what I'm gonna do is like in serialize, I'm gonna iterate in like pre-order fashion. So I would check the left, right, and the parent, and probably I would convert it into, the value. I would take it in an array, and then at the end, I would just convert the array into a string, right? So let's just go at it. So, all right. Let me say, so it's serialized, so I would want to create a function called func, and what should I name it? Encode, right? Just a helper function I would use here, just like that. And my serialize is gonna call this, of course, and this is gonna get called in a like a recursive fashion. And this, so it will accept a root TreeNode, and the return of this guy, I want to say it's an array, and um, I would say I should just convert it into string right here, right? Uh, or hmm, let me let me just keep it in for now. See how it goes. Okay, cool. All right. So that being said, let's just call um, encode from here, encode root, and let result is equal to encode root. And over here, what are we doing? We are checking if um, what's the idea that if the root is nil, the first thing we want to check here, then what do we want to do? Like if the root is nil, then I guess just return an empty array, right? Yeah. So, uh, okay. How about, let's just guard it. Guard let root is equal to root, else return an empty array, right? Because there it's null, so you just want to return an empty array. Otherwise, return, you want to process what's in the root's left. So that's what we said in code, that we're going to process the left and then right and then the value. Okay. So we will say return encode root dot left, and we have already optional binded it, so we don't need to do question mark over here again. Plus, so what I'm trying to do here is that, I'm gonna add all the arrays. So I'm converting you will know when I do this. 1 second, let me just finish up this real quick. So we're going to do process the left, then we're going to process the right, and then finally, okay, we're going to process the val, which I will just put it into an array, and then I'm adding all the arrays to give it a, the final array. And here I can just say root dot val, because again, I have already optional castrated. So what I'm doing here is that, I'm appending. So the result of this will be like an array, this will be array, and the value I put it inside an array. So all that will be combined, right? And this will be called recursively, and you will get your final array. And over here, I'm calling this and I'm saying what? So again, return. And so here, what's the idea? That idea is that to convert this array of integer into a string, I guess I can use join. So result dot joined. And what should I put here? I guess separated by, and let's just use and space. So now let's just see if this takes in directly, this integer to string conversion. I'll have to do it manually. I'm not 100% sure. I'll just do null over here and try to see, like compile it just to make sure. Okay, referencing instant memory join. String to equal to the solution. Yeah, that's what I thought. So that's what I thought. Basically, this may need a string conversion. So let's just do it here and change it to a string. I believe now it should work. Separated by, oh, sorry, yeah, separator. When you do components, then you do separated by. Okay, cool. All right, just wanted to check compilation errors. So far so good. Our encode is working. Well, not working, but at least doesn't have a compiler. Let's just give it a look at Deserialize. So what's the idea again? So the idea is that from the encode, we're gonna get this string, and we're gonna take the string like element one at a time. But one thing I wanna highlight is, like, you see, first I'm processing left, then right, and then val. So we have to like reverse it, because imagine if you have like let's say you have like over here, you have something like a tree like 2, and on the left of the tree, I should probably have something, but anyway, on the left of the tree, yeah, this way it should be, I think, not too bad to understand, right? On the left of the tree, let's say you have 1, and on the right of the tree, on the root node, you have 3, right? So root is 2, left is 1, and right is 3. So with joined, you will get actually like a string of 1 space 2, 3 space 2, because that's what we are doing. We are doing left, right, and the root, right? So once we get this back in the decode and we convert it, into an array back, our array will look like 1, 2, 1, 3, 2. So imagine this as a stack. We'll have to take 2 first, that would be root, 3, which is the right, and 1, which is the left. That's why I said the order of deserialize would be root, then right, then left, exact opposite of what I did in the encode. Okay. With that, again, let's create our helper function real quick. Deserialize. So let's call it decode, And again, this will take just a data of string, and I'm not sure what's the return it's going to be. Let's see. So what does the decode going to do? Basically, it's going to decode it, right? So, all right. So once we get the data form, which is a string, let's just real quick, let me think. I guess I can just convert it into an array right here. Okay, let's just do simple things over here. Let ARR is equal to array. And since it's a string and I wanna like separate it, so I guess I can do this data dot components separated by, and here we need separated by space. We can do a quick sanity check, if you guessed it, that if data dot count is equal to 0, then I guess you can just return no, right? You don't have anything to process. The data count is 0, so just return the guy. But if it has something, then my array is gonna be component separated by space. So I have this array which I was talking about up here. And I guess once I have the array, let's just pass our array over here. So I guess one thing I can try and be smart, little smart over here, is to do a compact map, which basically what I'm trying to do is like converting it into, from string to array, from string to integer conversion. So directly, rather than tackling that over here, maybe I can attempt to do it right over there. So 0, and we want it to return to int. So again, $0 is basically the first element of the array, which is what? Which is our 1, right? So yeah, 1, 2, 3. So we want to convert it into int, right? And difference between the map and compact map is that if something is nil, like conversion didn't work, then that value will be omitted, and that's what we want, right? We don't want any junk values. So what we said, data or component separated by space, that's going to give an array 1, 3, 2, and this compact map should convert it back to int. So array should be an ARR should be an array of integer rather than string. So we can just over here take array, which should be of type int, right? Okay, and this should return TreeNode, I think. Okay, cool. All right, and so we got that array, and I'm just debating maybe sanity checking over here we can just do over here, so that right, if the count is null, then it's, we don't have to double sanity check, just one should be fine. All right, so far so good, I believe. Let's just now think, what do we want to do over here? So in Decode, once we get an array, what do we want to do? Well, we have already tested that if count is 0, then let's just do that sanity check one more time over here. So if ARR.count is equal to 0, then basically return. And I'll tell you why I'm doing this again, because I am going to remove items from this array, and I want this recursion to stop once the count is 0. That's why I'm doing it again, in case you're wondering. So just hold on one second. So yeah, so if ARR.count is equal to return nil. Now, if it's not nil, then you want to take the because we are tackling it as a stack. So the very first element, and remember, we're gonna tackle the node first, like a parent node, then we're gonna do right, and then we're gonna do the left. It's so exact same opposite order of this one. So let's just get our last guy. So what we're gonna do is if let val or last item is equal to array dot last, and maybe I don't need to if let it because I know that this has something. This has a this count is not zero, so maybe I can just force cast it. So I got the last item here. Now, very interesting thing which I'm forgetting here. Remember, BST is a constraint on a tree, on a regular binary tree that which I said earlier, the left and right constraint. So in order to follow that constraint, I'm gonna have a left, which is an int, and I am gonna have a right, which is also an int, right? And here, what are we trying to say is that this constraint, which originally when I will call decode, will be like array, and I'm gonna say in.min, I believe it's small, yeah. And I am gonna say int.max. So it's just the minimum smallest boundary and the maximum boundary just to start off with. So here we want to say that if last item doesn't fall within this boundary, that means that we're gonna skip that. So if last item is equal to get, so just know what I'm talking about. If we will say last item, okay, is smaller than left, or last item is greater than right, which basically, and here you would be a little bit confused maybe because you think, hey, this is min and max, why this will be ever be less than left or greater than right. So just again, bear with me. We want to say return nil. This is not the right time. And again, I'll explain this thing just a bit. And then what I want to say that if it passes this filter test, then this is the right place for that value. So get that value. So what I'll say is that let val is equal to array dot remove last. Okay. I grabbed the last element from here, and I will say let root is equal to TreeNode, and maybe I wanna say it's nullable. TreeNode question mark of type, it's nullable, and value is gonna be val. And so we have created this node, whichever place this recursion is, and if the last item is within this boundary, then it's the right item to extract. So till here we didn't extract it. Right here at line 40 we extracted the element, take it out from the stack, created a node out of it. And if you're confused with this root, I mean, we can just name it node, because I usually get like, hey, is this root every time we are getting root? No, it's just a node. The final stack, or the first thing will be the root node, the first thing you extracted, because in this example, whatever is the rightmost guy is your topmost root of the tree. So let node is equal to tree node value, and we wanna say that node dot right or left. If you guessed it correctly, it's actually right because we're in the exact opposite order of this. So node dot right is equal to decode, and here is where I'm going to explain you ARR, and so we want to capture the rights. So we are saying the val is the parent, and what is gonna be the right node. So that would mean that it should be always greater than the value, right? So its left boundary will become val, and the right boundary will be right, whatever it was. And similar thing, let's tackle the left of the node. What will be the left? So if it's the left child, then the value of the parent, the left is always going to be smaller than the val. So here it's going to be left and the right is going to be val. And ultimately we can return the node. Gotcha. And sorry. So the very first time you're going to call the right, what it's going to be called with, you know, so what are we saying here? That our array is 1 and 2. This is our initial array, right? And we are saying, so basically our tree is going to look like 2 is the root node and 1 is the left child. And we are saying that first thing, when very first time it will be called, we will grab 2 because the last element, with the left int min and the right int max. 2, of course, is not less than int min and not, of course, greater than right int max, so it will not fall under this. And we'll remove 2 and we'll make it node, right? Then we'll call node.write and we'll call it with, array will become 1 because we have removed 2. And val is gonna be with your left, which is gonna be 2, and your right is again max, right? So we're gonna call this and it will come over here and it will grab the last item, which is 1. It will check, hey, last item, is it less than left? Yes, it's less than left because left is 2. So it's gonna return nil, and that's how it's gonna know that, hey, this is not the right child. Then it's going to go to left and it will call with, again, array 1. And the left will be basically min, and right is going to be your 2, right, your val. And we're going to come over here and see the last item, which is again 1. And is it less than left? Yes, it's less than. No, it's not less than left because it's int.min, right? Hey, or last item, is it greater than right? No, it's not greater than right. It's 1, and so 1 is not greater than 2. So it's not going to fall under, and that's how we know that, hey, the val is actually correct. Remove it, and now this will be ultimately be returned to the left child of the node and not the right child. That's the logic. That's why this will work. So let's just give it a shot real quick. First of all, Decode is going to give us a tree node, and we can just return this. So let's try to run it and see if I've made any compiler. Yes, I have done it. I don't need if here. Let last item. Okay. Mutating member ARR. Okay, so I think the problem over here is that, so let's say you have, again, 2, 1, and 3, right? And the very first time 3 gets removed and you will be left with 2 and 1. You call write, and sorry, not 2 and 3. So very first time it's going to be 1, what is my stdr? 132. That is what the decode is going to get, right? So the very first time 2 will be removed and you will pass 1 and 3 to write. Now in the recursive call, when write would call the decode, it will also remove 3. Now when it comes back to this call, the earlier stack, what's happening here is that Decode is calling with the same array snapshot, which was 1 and 3, and not with just not with just one, because the right call actually removed already three. But this stack doesn't know that because each stack is maintaining its own variable. So I think the problem over here, what I did was the silly one, that I should make it, instead of, like passing by value, I should pass it by reference. So let's just quickly try that. So inout is how you do in Swift. Just change this to you're passing memory now. And now we don't need that, because once it's a memory reference, you can actually change you know its stuff. So over here again, pass it by memory, and this may not work here, because for memory you have to be aware, not let. And let's just give it a try and see. Okay, and as you can see, uh, and submit. Okay, yeah, as you can see, I've already tried that. Yeah, that was the issue over here. All right, cool. Thank you guys. Hope you enjoyed it. And see you next time.